11.7 is the last section in Unit 11. The whole chapter has been about quadratics and figuring out where the roots, zeros, solutions are, where the graphs cross the x-axis. In the last section, they try to make a connection with what you did with what you learned back in Math 1, or, yeah, most of you came from Math 1 anyway, so there we go, from Math 1. You're going to see where a quadratic intersects a line, and you're going to find two solutions. So, the first thing you need to know is that a system of equations is where you have two or more equations. And so in these systems, we're going to be figuring out where a parabola crosses a line or two lines cross each other. The way that we're going to do that, we're going to use two different methods. The first method is graphing. The second method is algebra. If you are graphing, you need to make sure you are accurate. If you are making your parabolas and they're not accurate to what the shape is, then where they cross may not be correct. So I'm going to recommend you may want to use Desmos to double check your graphs. If you do not know how to sketch these things, use Desmos.com. But if you do know how to graph them, you should be fine as far as the graphs go. Just make sure you're accurate. The second thing that we're going to do is we're going to do this algebraically. Make sure that they are equal to 0. You're going to set the two equations equal to each other. You can then choose to factor or complete the square or use the quadratic formula just like you did in section 6. And the last thing I need to say before we get to examples is that sometimes the two graphs will not intersect each other. I think there's at least one of them on this worksheet. If they do not have a solution, then the two graphs do not intersect each other. That's something that you might want to be ready for in case it happens. So I have chosen number 2, number 5, and number 11 for us to do together. Number 2 on your worksheet says this: find all solutions to f of x is equals to g of x. Part A, solve by graphing, and part B, solve algebraically using substitution. So we got to know both ways to do it. There are two equations here. There is f of x. I'm going to circle that in red. And then there's g of x. F of x is a parabola, and g of x is a line, linear equation. So we're going to graph this. And if my memory serves me correct, for graphing 2x squared plus 1, I can think of that in terms of it's pretty darn close to vertex form. And I know that I'm adding nothing inside that x squared. So I know what my x coordinate is, and I know what my y coordinate is. My vertex is at 0, 1. So I'm going to put it 0, 1. I'm putting a dot right there for my graph. And I know since the a value is a 2, it's a positive value. It opens up and it's narrow. So I'm going to go to the right one up 2, to the left one up 2. And I'm going to make a sketch real quick. I'm just trying to be accurate as I can with this sketch. I know it's going to be something like this. I'm not sure exactly how it's going to look, but that's my sketch for the red graph. G of x is a different function. It's I'm going to circle it here in blue. I'm going to graph it in blue so you can see a difference. This is a line, and we haven't talked about how to graph a line because you should have learned that in Math 1, or last year's math class. What you learned is that this is y equals mx plus b. This is your y-intercept. It crosses the y-axis at positive 5. Up, 1, 2, 3, 4, 5. And this is your slope. The slope is down 2 as a fraction, down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. It makes a line. I'm going to go to my line. And I'm just going to draw a line from here. There's a line. And so the hard part about this parabola is that because I sketched it, I have to go, where do these two things cross? I could see it probably cross right here, and it cross maybe right there. So I kind of have a guess right now. I'm going to put some numbers here. 0, 1, 2, -1, -2. I'm putting those numbers there. I'm also going to put numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right now, as I look at this, because my graph isn't very accurate, I go, it might go by right here 1 and 3. I think that's the same point, 1, 3. I'm going to put that for sure as one of my answers. These are equal to each other. A solution to what are the same is 1, 3. And then we have a secondary answer somewhere over here. I can't tell if it crosses at 8 or if it crosses somewhere else, but it really looks close at -2. So here's what I can do with this graph to make sure I'm being accurate. I can plug in -2 into this equation just to see where it is. -2 is where? 2 times 2 is 4, times 2 is 8, plus 1. It's actually supposed to go through 9, right there, 9. Now what about the blue equation? Where is it at -2? Let's find out. Negative times a negative is a positive. Oh, it goes through 9 as well. So that tells you that your second solution is at -2, 9, based off of those graphs. That's why it's hard to do this with a sketch, which is a reason why you may want to type it into Desmos if you want to see if it's accurate. Part B, solve the system algebraically to find out when f of x is equal to g of x. Well, what does that mean? That means that you can take this equation, the 2x squared plus 1, and you can set it equal to the -2x plus 5. We want to find out where are these equal to each other. What I said in your notes was make sure it's equal to 0. Put it in standard form. Add the 2x and subtract the 5. Add the 2x and subtract the 5. 2x minus 2x goes away. 5 minus 5 makes 0. On this side, you cannot combine them. They're not like terms. But I can combine the -5 and the 1 together. And just like the previous section, you have a choice. Should I factor it? Should I use the quadratic formula? Well, first thing I see is a 2, and a 4. I'm going to factor out a 2 and just to see what this looks like. This looks pretty small. I bet you I could factor it fastest. And as I check to see, does this factor to that? It does. And that means that there's going to be some solutions here. 2 can't equal 0. That doesn't give me any solutions. But the x plus 2 can equal 0 when x is equal to -2. The x minus 1 can equal 0. It could give me a solution when x is equal to +1. So when I look at it algebraically, I know that it's going to have a solution at -2, which is what we found for the x coordinate, and +1, which is what we found for the other x coordinate. These are where your x's that make this equation the same as that equation. They're solutions. If you want, you can plug them back in to find out what the y coordinate is, and you'll see that they are exactly the same. For right now, all I care about is you finding the x coordinates where they are congruent to each other. which is what we're going to do on our example for number 5. Now they don't have you do it with graphing. Now they just say solve it algebraically. Where is f of x equal to g of x? So what do? We set them equal to each other. I'm going to put this one over here. Set that equal to this guy. Then what? Add x, add 7 to get this in standard form. Add x and add 7. This will make 0. That makes 0. X squared minus 3x plus 2 equals 0. I have a choice. I can complete the square. I can use the quadratic formula. Or if it factors easily, maybe I should just factor it, because sometimes factoring makes things go a lot faster. That multiplies to be a positive 2. It adds negative 1x, negative 2x makes negative 3x. And then you can find your two solutions. When x is 2, using the zero product property. I know these two equations will be equal to each other. They'll cross each other when x is 1 and when x is 2. If I want to know what the ordered pair is, I can plug the 1 into either equation to find the y value. Most of the time, you will have two solutions because a parabola and a line cross each other in two spots. But it is possible for it to touch in one spot, or it is possible for it to not touch at all. So keep that in mind. Two solutions because it crosses in two places. Number 11 is the last one I picked for you. Where are these equal to each other? Well, let's find out. Let's set the first one equal to the second one. We'll add 3. Let's get it equal to 0. Square root. The square root of 0 is 0. So in this case, there's only one solution that is equal to where it crosses at x is equal to 0. Just so you know. I'm going to end your notes right there.